Hi, Calculus. It's Mrs. Jarosik. I am coming to you with 3-7 chain rule notes video today. So pause and get yourself either the uh, visual of the 3-7 notes out with your notebook or print out the notes for yourself to write on. And we're going to get started. The good news about 3-7 and 3-8 both actually are they're very computational, so we need to practice a lot, which we will do in the video. A little less with conceptual on this one, but a lot more computational. So we'll do a lot of good examples so that hopefully by the end of the video, you have a very good feel for it. I know that I have a lot of trouble during class time getting through as many examples as I would like with my classes. So I'm going to do much of what's on the notes sheet for you today so that your teachers can practice with you on the many other very good documents that we do have available with practice on them. Okay. So in order to show the chain rule, I actually do want to do the first warm-up question with you using product rule as it indicates. So find the derivative dy dx of the following, y equals x plus 2 cubed. So if you want to pause and do that, I think that would be a great idea. And I'm going to go right into it, but you can pause and definitely give it a shot yourself, see how good your product rule is, right? So I always take, I actually meant to write this first. That's what I meant to do first. That's what we're talking about. And then for product rule, you take one derivative at a time. You have three expressions being multiplied together. You take the derivative of one at a time. So I usually just, work it left to right across, and it's all multiplication and addition. So they're all commutative. So it doesn't matter which order you go in. And I'm sure that your teacher plus the video Mr. Levenworth did went over both of those ideas. Okay. So just to show that I am taking the derivative of one part at a time, this is the derivative first part, left the other two alone, plus derivative, leave the first one alone, take the derivative of the second part, leave the third one alone. And then of course, we have first two, and then the third one is what we take the derivative of. So what we have in the end is x plus 2 squared plus x plus 2 squared plus x plus 2 squared, which is 3x plus 2 squared. Okay. All right. So what I'm going to do is I'm going to jump right into chain rule with you, starting with what chain rule actually looks like in its formula form, if you will. So as you can see, the first thing is that we apply chain rule to things that look like compositions, right? Composition of functions. So we have an inside function, g of x notated here, and we have an outside function, f of x. Okay, so when we do composition problems in Algebra 2, we always work inside out. So you could think of it almost in the opposite way, in derivative sense. You take the derivative of the outside function first, then the inside function. And I was mentioning this in my class, the one thing to remember about derivatives, you might be taking derivatives in multiple steps, but you never take more than one derivative at a time, okay? You always take them in parts. So any function that's in your problem eventually gets its derivative taken. So there might be multiple things composed, multiple functions composed into one problem. You take the derivatives one at a time, okay? So let's see how this is going to actually work after we go through a little bit of how this is expanded once we take the derivative. So notice I said you take the derivative of the outside function first. So there is f is our outside function. So we take f prime, leave the inside function alone. So it's f prime g of x. And then we multiply by the derivative of the inside function. Chain rule. Okay, and if there are multiple inside functions, you work from the outside in, one at a time. And you would just keep multiplying at the end by the next inside function. Okay. All right, so a lot of times what we end up doing is using chain rule with power rule. So I'm actually going to show you on this one, the one we just did with the warm-up, how this would work, because you can use chain rule on this one as well. So our outside function, so let me talk about that real quick. Outside function. Wow, a little trouble here today. So in this case, our outside function, if you will, something cubed. Inside function, should probably change the color on that a little bit, would be then x plus 2. Right? So if you want to think of the outside function as something cubed, I don't like to say necessarily it's always an x, just because the x's then get a little confused. But our outside function is something cubed, and then the inside function is x plus 2. So if we follow chain rule, this up, if we follow how chain rule is supposed to work, we have power with chain. This is a power with chain idea because the outside function is a power function. So you apply power rule with chain. So power rule says you multiply the exponent by the coefficient in front. That's our 3. You are leaving, this is now chain rule part of this, you leave the inside function alone, because right now I'm working on taking the derivative of the outside function. So that would mean it's power rule. That means I subtract 1 from the 3. So I've applied power rule now. Chain now says you take the derivative of the inside function. Okay, so the derivative of the inside function, right, would be times 1. Symbolically putting it down, because now I know I did that, I can write the final answer then as y prime equals 3 times x plus 2 squared, which is exactly what we got there. Okay. All right, I'm actually going to, because I don't think I have one here. What I'm going to do is slightly change, a little off script here. If I were to do this, definitely wouldn't want to use product rule on this now, right? You certainly don't want to have to do this 5 times and put it all together. Let's use chain rule. Chain, power with chain, okay? So our first move is to apply power rule. 5 gets multiplied by the 1 in front. I leave the inside alone. I take 1 away from my power. Now I multiply by the derivative of the inside. And in this case, it's nothing symbolic. There's an actual negative 3x that I'm taking the derivative of, which means I multiply by negative 3. So that would mean my derivative is negative 15 times negative 3x plus 4 to the 4. All right, I want to go back up to the other warm-up and do this one actually by quotient rule, because we're going to do it by chain rule as well, but I actually want to do both quotient and chain to show something, make a point. Because it seems like with the product rule one and the chain, I would say that the chain, even in both cases, much easier than the product rule version of this. Not that product is wrong, just easier with chain. All right, so I'm going to go to quotient rule. Right, so quotient rule says low d high minus high d low rho squared. So my students probably saw me do this in class, right? So I'm just going to explain it. Low refers to our denominator. Okay, I'm going to get that over here. Low is denominator, high is numerator. So that when you're going through that thing in your mind, when you're talking about quotient rule, so you don't lose the order you're supposed to go in, you can say low, d high. So denominator times derivative of numerator minus numerator times derivative of denominator. Low d high minus high d low over low squared. Okay, so here we go. Low. 3x squared plus 1 times derivative of high, that's 2, minus high, so that's 2x, derivative of low, 6x, over low squared. All right, so I'm not going to do anything with the denominator. I'm just going to simplify the numerator a little bit. 12x squared over 3x squared plus 1 squared, which then becomes negative 6x squared plus 2 over 3 times x squared plus 1 squared. 6 negative 6x squared plus 2. I can take a 2 out of here. It's not going to help me simplify anything. So if I just think through that real quick, if I take a negative 2 out, I would get a 3x squared here, but then that would be minus 1. So I'm not matching up with that. Okay. All right. Okay, that was quotient rule. Not too bad. Got that. Okay, so let's go to chain rule on this. So if we're going to do this by chain rule instead, notice this. It has to be rewritten first. And when we say rewrite, we are going to write this as something to the negative 1 power. Okay, so we are doing, okay, we've got a couple of things going on here. We actually have a power with chain, okay, and we also have a product rule going on, okay. So you need to take, so product rule with power and chain. I guess that's how we could look at this. So it's more or less this function times this function, and the second function is a power with chain. So there's a lot of stuff going on here. I don't know if you're already saying to yourself, I probably liked quotient rule better, and you're probably right. But let's try this. Leave myself a bunch of room here. So product rule says you have to take the derivative of one of the expressions at a time. So if I start with the first one, 2x. 2 is the derivative. I leave 3x squared plus 1 alone. Plus, right? Now I have to take the derivative of the second piece. So you have your options. You could do that right now and in front. You could also rewrite the 2x and then deal with that. So your preference, I just made my own decision to do it this way. So my negative 1 comes in front, times 3x squared chain rule, 3x squared plus 1, I leave it alone. And then negative 1, I actually want to erase my parentheses real quick because there we go. Negative 1 minus 1 is negative 2, right? Okay. And then derivative of the inside function, which is the 3x squared plus 1, so that's times 6x. Now, I'm not saying that that's terribly, terribly hard to look at, but there's some simplifying to do. We could combine, because it certainly doesn't look like my answer yet that I had up here. So let's put some stuff together. That would all be minus 12x squared. Agreed? And then this portion right here would be in the denominator. Bring it back down with the squared. Okay. And then this would be, I guess I could do this, right? That's a minus sign in front. Get a little more used to my fun pencil here. 2 in the top, bring the 3x squared plus 1 to the bottom. Now, it still doesn't look the same, right? But do you notice it's a common denominator of 3x squared plus 1 squared? So if I actually did that, this right here, if I made the common denominator for this and put them together, then we would get the same answer. My personal opinion, I think quotient rule on something like this is easier, but that's just me, especially if you have to pick a multiple choice question that would be simplified. Okay. All right, saving some time, I would do the simplification on that second one, but let's save some time so this doesn't get too long. Okay. So some helpful hints here. Remember that rewriting the function first may help in some problems. A lot of times with power rule, you simplify first. With any of them, if you can simplify first, it will make your life a little bit easier. Okay, and you may be using more than one rule at a time. All right, so let's try this. So right here, we've got power with chain. Okay, so we start with, this one looks relatively straightforward. Power rule comes first, 3 times x squared plus 2. Take 1 away, it's 2, okay, times, 2x, derivative of the inside. Okay. It can be simplified as 6x times x squared plus 2 squared. Okay. All right. 4 and 5. Why don't you give 4 and 5 a try? And then I will go over them, but why don't you give them a try? Pause and see how you're doing so far. This would be a good time to give yourself a check. Okay. All right, dy dx. Remember, dy dx is the same thing as saying y prime. So dy dx, right? So power with chain again. So 50 times x squared plus 2 to the 49 times 2x, derivative of the inside. So 100x times x squared plus 2 to the 49. Okay, this was right there. All right. Let's go over 5. Okay, here we go. Product, power with chain. So overall, it's a product rule problem, but we have power with chain. Feel free to multiply all this out if you really want to, and you can just use power on the whole thing. I'm sure that's probably something we're looking forward to doing. So for product rule, 1 derivative at a time. So I'm going to take the first one's derivative. So x squared derivative is 2x, leave x plus 3 to the 4th. Plus, leave the x squared alone and take the derivative of, okay, my symbolic 1 for chain rule, so I don't forget chain rule. Okay. The only one I can really clean up would be that second one. I'm not going to multiply anything out right now. So this times this times this gives me a 4x squared times x plus 3 cubed. Okay. All right. And hopefully you are all doing okay, trying your pausing and trying. Okay. So again, pause. go ahead and try 6 for yourself. All right, here we go. Derivative of x cubed times g of x. Love these problems. When you've got two functions, there are no, outside of the exponent, there's no numbers. So, product rule overall. So, it's an x cubed times a g of x function. All right, so derivative, I should say d dx of x cubed times g of x is, here we go, 3x squared times g of x plus if g of x is equal where? Oh, is that g of x is 5? Oh, you know what? Derivative of g of x is 5. So that means what? G prime is 5. So I'm actually doing the 5 over here. I almost missed that myself. Derivative of g is equal to 5. So for final answer, all right. So I actually think, because I think this is, we're kind of close to the end. Yeah, okay. Sorry about that, everybody. I wanted to kind of see where we were going with this. I will definitely do 7, a radical, and I will do either 8 or 9, okay? So I'm thinking on the fly right now, I guess I'll do, maybe I'll do 8. Just do these 2 and save 9. You can check that in your notes. Okay, so we need to do a rewrite on 7. So y is equal to x times x squared plus 3 to the negative 1/2. Okay. So when we go to take the derivative, 1 times x squared plus 3 to the negative 1/2 plus x times negative 1/2 times x squared plus 3 to the negative 1/2 minus 2 halves, or negative, right? Negative 1 is negative 2 halves. That'd be negative 3 halves. Okay. That's a really, really not good 3. Let me redo my 3. It's not much better 3, so let's quit while I'm ahead. Times the derivative of the inside. Right. There we go. Really, if you want, you can clean this up in this manner. So the 2x and the x can stay in the top of the fraction, if you will. Pardon me. 2x times x times 1/2, negative 1/2. So let's actually do this. This, and this can all be combined. So that would mean actually I end up with negative x squared. Huh. I'll get rid of that plus sign. Minus, right? X squared, right? Over, okay, in a radical form, negative 3 halves would mean the square root of x squared plus 3 cubed. And if we really wanted to get crazy, we could do what? Mr. Leavenworth had put this in his video as well, since we have something that's cubed underneath a radical. You can take, right, you can take 1x squared plus 3 out, and you have an x squared plus 3 left underneath, which is what you have here. The other thing to think about is, instead of simplifying, would doing quotient with chain be easier? We're not going to do that right now, but also another approach. You could do quotient with chain. Okay. That there. It's our first video with the new pen, with everything going on. Sorry about that, everybody. Okay. Wrap things up to power. So good. Pause a minute because I don't know if I'm getting a bad connection. Got a little warning there. I want to make sure you can hear me. All right, so we have a quotient. Inside function is quotient, and the outside function is power. So it's interesting. We're going to do power with chain, but the chain is the quotient rule. Okay. So I'm going to change colors. Let's go with purple. And we are going to give this a try. So I start with power rule. 2. Leave the inside alone. Oh, I just noticed that. That is not going to give me enough space at all. So my apologies. I'm going to give myself a little bit more room first. I'm going to take it all the way down here. X squared plus 3 to the first power rule times. Now my chain rule is actually a quotient rule. Low D high minus high D low over low squared. There we go. Low derivative of high minus high derivative of low over low squared. Okay. Good news is it's on free response. You don't actually have to put all this together. But for the sake of making it look a little bit nicer, right? This is all multiplied together. It's a big old times in the middle there. So we have x squared plus 3 cubed on the bottom. And we have 2x plus 8 times, put some of this together, x squared minus 2x squared, so that's a minus x squared minus 8x plus 3. Okay. All right. Okay, I think then we have a couple of more at the bottom. These are actually writing tangent line equations. Maybe what we should do together just to practice a little bit, since we're post 3, 5, 3, 6, just to practice trig derivative, let's maybe do 11 together. So the directions say evaluate the derivative of the function at the indicated point and write the equation of the tangent line at that point. Notice tangent lines keep coming back. They are never going to leave. So we need f prime, or I guess in the case of what's written there, we want dy dx, excuse me. So dy dx and f prime are the same thing, but let's use the notation they're asking for. So constant multiple rule, so the 1/4 stays. I take the derivative of cosine. What's the derivative of cosine? Negative sine, chain rule of 5x, derivative of inside, times 5. So I brought the negative out front while I was doing the derivative of cosine. So I end up with negative 5/4 sine of 5x. That is my dy dx. That's my slope. At that point. So I wonder, this must be an old version of, I'm going to make up a point right now because where's the point? At that point. So let's make a point of 0, 1. Okay. If that's the case, cosine of 0, so, excuse me, 1/4, this would be, right? 0, 1/4. So if I plugged in 0, right, for cosine, right here, cosine of 0 is 1, 1 times 1/4 is 1/4. Well, there's my point. I'm not sure where it went on the notes, but it disappeared on me. Okay, so y minus 1/4 equals, right, x minus 0. And now what we need to do is actually go ahead and plug in 0 here for sine. What's going to happen, everybody? That zeroes out. So if we actually plug 0 in for x, sine of 0 is 0. Well, what do we actually have then? Y equals 1/4. It's horizontal. Right. Okay. All right, that's going to wrap it up for chain rule. Hopefully that was enough different examples to get you through your homework and before your next class. Okay, have a good night, everybody.